Today we sit down with Bob Galyen, the former CTO of CATL and founder of Galyen Energy. He's recognized as one of the top executives in the battery energy storage world. This standing comes from his positions as the former CTO of CATL, coincidentally the world's largest battery manufacturer, chairman of SAE International Battery Standards Steering Committee, along with chairman emeritus and CTO of NAATbatt International, a leading battery trade group. All of this experience provides him with a unique leadership perspective in the global battery industry, along with holding degrees in chemistry and biology. Today, we discuss everything from his background and career at CATL to Tesla's Battery Day, along with his thoughts on electric buses, autonomous vehicles, and where the industry is heading. Connections. Today, I'm joined by Bob Galyen. He's the former CTO of CATL and the founder of Galyen Energy. Thanks for joining us today, Bob.
Well, thank you. It's very nice that you could ask me, Chase. It's been a few weeks since we worked together on the radio and TV together, so I'm looking forward to this interview. This sounds kind of exciting, and I might mention today was the beginning or the launch of the battery show virtual this year because of the COVID virus. So this morning I gave the chairman's welcoming address for the battery show. So it's been a bit of a busy day today so far.
Yeah, I think I want to say thank you again for not only your time today, but when we did get to speak a few weeks ago discussing Tesla's Battery Day, we were able to cover a lot of great topics. And I realized I think it'd be great just to kind of have a one-to-one to learn a bit more about your background and where you see the industry going. Obviously, you've had quite the career working at CATL and even now as kind of a consultant and previous to that. So I think with that, I would love to just kind of learn and hear a bit more about what originally caused you to become so excited about battery technology and how you got to where you are today.
Well, it's a bit of an interesting story, to say the least. I was going to Ball State University, famous university for David Letterman and Papa John's and Garfield and some of those notoriety type of people in media and in marketing and sales type of careers. But you don't hear too many people from Ball State in the technical field, but I'm one of them, and been very quite pleased in the education I got there. And I still sit on the advisory board for the Dean's Executive Advisory Council at Ball State. I just had our meeting with them just a few days ago. But I started out with a degree in biology and chemistry, a double major. So I got a double bachelor's degree in 4 years, and later went on and got my master's degree in chemistry. And it was during that time working toward going to medical school that I inherited a genetically inherited tremor from my mother. So it's not a great thing to be a surgeon and leaving a few jagged edges along the suture line. So it was a bit of a challenge for me to be a surgeon with a familiar tremor. So instead, I was offered a job by Delco Remy division of GM because I was working there as an 89-day wonder, and started working in their laboratory. My very first job out of the gate was to do analysis for the silver zinc battery for the Minuteman missile. Delco Remy at that time had the contract for the intercontinental ballistic missiles, and I was doing that chemistry. And then they said, well, yes, you're so proficient at doing this, we're going to put you in what they call a college graduate training program for a year. So I had a great opportunity to learn about horn switches, solenoids, and things like that that Delco Remy made at the time, but they were also the world's largest battery manufacturer. And after that 1 year stint doing the college graduate training program, I went on to work in the chem lab on nickel zinc batteries, because at that time we were trying to perfect the nickel zinc battery for electric vehicles. But instead, they pulled me out of the laboratory and put me into advanced engineering, where I worked with General Motors Research, working on some of the sophisticated math modeling for lead acid batteries with Dr. Hiram Gu, and some sophisticated physics with Dr. Don Sweats, who and I, working with me, were trying to identify the metrics that would go into the math model by measuring conductivity of active materials. So that really got me fascinated about batteries because there's so much science involved with it. And I was able to apply my chemistry, my minor in physics and minor in math. Biology didn't play such a big role, but later I did find out that it did. But that's what got me really started in batteries. And then I was quite fortunate to move through nearly every engineering role at Delco-Remy before I was given a special assignment to go out and start the world's largest battery separator plant as a dedicated supplier to Delco-Remy. That company's name was Intech, and later Intech became Intech-Cookson, which is the biggest separator organization in the world. And shortly after finishing that, I was put on a special assignment to go out to California and work with a Dr. Paul McCready at AeroVironment. He was working on a futuristic car for General Motors called the Impact. The Impact was the precursor to the EV1. After we got through doing the prototype car, the corporation was so excited about this that they did start putting together a prototype production line and produced a little over 700 EV1 cars. And I was quite fortunate to be on the vehicle integration team as one of the 7 guys that helped put the vehicle together. It's quite an education to build a brand new car from ground up. And at that time, they claimed that it was the second most complicated vehicle ever built, right behind the space shuttle, because of all the technology that went into that car. And then after working on the EV1 program, I got moved into a special assignment as what they call a super project manager, where I had 7 major projects that were each one well over $100 million in value, and got to work on that. And then it got me promoted into the chief engineer seat at then Delphi, because we spun Delco-Remy out of General Motors to become Delphi. And after about 3.5 years of that, I decided it wasn't for me. It was time to move on, and I started my own company. And I ran my own company for about 9 years, which was a technical service company that created value to customers by doing technical field service and consultation services, along with warranty administration and materials analysis, because I bought a materials analysis laboratory from Delphi because of their financial woes, and used that laboratory in doing a lot of the fundamental testing and evaluations that were required for that kind of a job. Then I took that business and put it in to the pool for sale at that time with Magna International, because Magna was wanting to start a brand new division that would start making electric car components. And I was fortunate to sell my business to the Magna International team. Frank Stronach and Don Walker, the owner and the CEO of that company, had lunch with them, and they bought the business on the spot. And then I ran that business for about 3.5 years with offices in Auburn Hills, Michigan, and in Aurora, Canada, and Graz, Austria. So I had 3 different offices and rotated between those 3 offices. And after about 3.5 years of that, I had some difficult conversations with Don, and I love Don because he's one of the best CEOs in the world, who's going to retire this year. Don and I were having a discussion. I said, Don, we really need to work in China, because that's where the next revolution is going to happen. That's where the money's going to be. He said, Bob, I don't really want to work in China right now. It's not the best timing. It's not what I want to do. But little did I know, I was going to Shenzhen, China, for giving a presentation on behalf of SAE International. And I was quite fortunate to run into a young gentleman by the name of Dr. Robin Zhang. Robin Zhang, his Chinese name is Yichun Zhang. Robin was probably one of the smartest young guys I've ever met. He invited me to dinner with some of his engineering managers one evening, and I really enjoyed talking with these guys, and had a great time talking with them. And I knew I'd been set up because in the center of each of the tables of the dining hall was a copy of Batteries International. I had my ugly mug on the front cover from an article that was written as the first person ever to be put on the front cover of Batteries International. So I was quite interested to see what these guys had to say. And little did I know that Robin was really interested in asking me to come work with him. So by April of the next year, he and I met in Cupertino, California, because he was out there to meet with some small company that makes cell phones. And right. we hit it off, and Robin invited me to come work in China. So by July 1st, I was in China and started to work for ATL. And 6 months after being there in December, Robin asked me, he came down to my office and said, Bob, would you consider moving from ATL over to this new company we're starting called CATL? And I said, well, what is a CATL? He says, It's called Contemporary Amperex Technology. He says this is a brand new company that we're starting up to supply the electric vehicle market. And this electric vehicle market requires that the predominant ownership be from Chinese-based ownership above 51%. And so I said, sure, I'll do that, Robin, because I promised you I'd come over here and help you build a company. Well, little did I know, within 5 years, it would become the biggest in the world. And as employee number 2 in the corporation, it was quite a testament to see that company grow so rapidly. And I have to say that I've never seen anything quite like it, and neither had the Chinese. I believe it's still considered the fastest growing company in China on the industrial manufacturing side. But I promised Robin I'd spend 2 more years, or 2.5 more years in China to help him continue to grow the business. And then at the end of that 2.5 years, it was time for me to come home, spend time with my wife and my children and my 7 grandchildren. And that's why I came back at the end of November last year. So that's kind of a quick background of where I've been, why I got fascinated by batteries, and where I am today, which is a fascinating role in the industry of being a senior advisor and consultant to several different companies that helps the propagation of electrification in the industry today, and then some agricultural and chemistry and biology functions as well. So that is a quick rundown of what's happened to me in the last 43 years.
I was going to say, is that all? That's that's very impressive, needless to say. I am curious. You did mention early on about your background in biology and how that kind of played into your career later on. Could you share just a little bit about that?
Sure. Because I was working, I got my bachelor's degree in biology. I was always fascinated by microbiology and the role that biology played in the medical field. But little did I know that once I retired from CATL, that when I got back to the United States, there were some companies that were interested in the use of my knowledge in the battery, or not the battery field, but the science field of biology and chemistry. And that company is called Tigris. Tigris is a very interesting company that they're working with hydronium chemistry. Hydronium chemistry is a little understood technology that is a water solution. And what does that mean? It means that it's a protonated solution that is stabilized in what they call Eigensundel clusters in the scientific world. And we found that this technology is applicable to so many different fields. It's just amazing. We did find out through doing tests with Dr. Tony Ataya from Wake Forest University, heading up a DARPA program, that it kills the COVID virus in less than 1 minute at 2.5% concentration at the 5-log kill rate, which is an absolutely fascinating thing for us. But that's not the primary thing that we're focused on right now. What we're really focused on is its ability to be put into agricultural use, where it can increase crop yields by anywhere from 10 to 60+% in almost every crop that we've tested it on. So right now I'm working aggressively. I'm working very aggressively with different universities, Ball State University, Purdue University, University of Kentucky, Indiana University, and some other universities that our CTO is working with to classify the chemistry, understand the mechanisms so that we can really value its net worth to the world, because we believe that this is a chemistry that's transformational and it's going to change everything. So we're quite excited about that, and got to be a little careful I don't get into any non-disclosure agreement topics here, but I think that the company is going to be one of those companies destined to change the world, much like CATL did. So that's it's the biology side of it is really fascinating, Chase, because if we understand what is going on in the mechanisms of this hydronium chemistry, it does have a chance to help feed the hungry of the world in a way we've never seen before, because we've never seen anything that creates growth enhancement in plants like this, and it's a perfectly safe solution.
That's amazing. I'm sure I was interested in talking about battery technology, but that's probably just as important, if not more so, learning how to be able to get more food out to all over the world. That's amazing. And quite the tangent from some of the other stuff that you've done in your career, but also very impressive. Going off
Well,
of the growth you mentioned you saw at CATL, and it sounds like that this other company you're working for will see probably an amazing amount of growth too. So we look forward to hearing more about that when you can share it. However,
sure.
with CATL, you mentioned you started as employee number 2. Can you share kind of some of the maybe some of the stories of like what really led to the massive growth of CATL becoming the largest battery manufacturer in the world, and maybe some interesting things you learned along the way that really helped propel the company?
Well, to be consistent with my storyline from the battery show 7 and 8 years ago, when they asked me to be the chairman of the battery show way back then, and I've been there for every year since as the chairman, I gave the speech regarding that growth in this way. Where in the world could you ever go where there is a fundamental need for a new technology to help save humans' lives as well as help the economy? And the Chinese government was very smart in the way they did this. They created incentives for people to buy electric cars because China tends to be a very populated area because of their over a billion people in their population. And the cars that people drive over, there's no different than the ones we have because they're just made in China. But to look at the amount of pollution in the 4 metropolitan areas of China alone, just Beijing, Shenzhen, Tianjin, Shanghai. You just think about the pollution that's caused every day by the amount of cars that are running around on the roads. It's huge. So they had a strategy to decrease the amount of pollution in several different categories. One was coal burning plants. They're going to start shutting those down or put cleansing towers on each one of those coal burning factories that generate electricity. They were also going to reduce pollution by electrifying buses. And the bus market was really what launched CATL out of the gate like a racehorse, because there was a dire need for decreasing the pollution and a need for moving mass number of people. And what better way to do that than with electric buses? So at the end of 2018, there were approaching 800,000 electric buses on the roads in China with CATL batteries in them, which is a pretty amazing story in itself. And then the car businesses started ramping up, because during the time we were building all these electric buses, all the car companies were running to the finish line because there was incentive packages from the Chinese government to create electric cars. So pretty soon the electric car market started ramping very quickly. And pretty soon the two lines crossed, where the car industry was requiring more batteries than the electric buses, because the bus market was becoming a little closer to saturation than the cars. So it really propelled CATL to the top of the stack in terms of annual production volumes, because the government supported it. They offered incentive packages. They offered incentives to people to buy the cars. And they also gave businesses like CATL the opportunity to grow very rapidly through favorable financing, even though the government never gave CATL money. But it was quite a testament during those first 5 years to see how things would grow and grow so rapidly.
No, I mean, that's wild to hear and very impressive. What you mentioned about the bus growth kind of saturating and then the car growth taking over, did that turn out to be also part of like a really good launching bed? Because I know CATL has now expanded obviously to factories all over the world. Can you share maybe any insights that you gained by kind of taking what had been built for the bus market and then taking it to the next level for kind of the more just average electric vehicles?
Well, there's a big difference between the bus battery packs and the electric car battery packs, because the car's energy densities required a different chemistry to get the kind of energy densities required to get the range that the consumers would expect. Nearly all the buses in the first 5 years, if not all, had what we call an LFP chemistry in it. Lithium iron phosphate is a very safe chemistry. It is less prone to abuse than other types of chemistries. It has great cycle life, and it behaves quite well in wide temperature ranges. So nearly every bus that we put on the road for the first several years had lithium iron phosphate batteries in it. It wasn't until the need of getting higher energy densities for passenger cars that we started making the trimetal chemistry of nickel, manganese, and cobalt. And because of proprietary issues, I can't say a whole lot more about that other than that CATL made several different kinds of NMC technology over the years. And certainly they're pushing very hard to try to decrease the amount of cobalt, because as we all know, cobalt is the major cost factor in most of the NMC blends, and we're trying our best to reduce that amount of cobalt. So consequently, that's why you see nearly every major car manufacturer, every battery manufacturer today using 811 for NMC technologies, because it uses much less cobalt and a lot more nickel.
Yeah. You mentioned the need of the range for the electric buses. What could you share kind of roughly what the average pack size for something like that would be, and maybe what their range would be?
Well, the bus battery packs is kind of a different configuration because they do have the space under the passenger to put the batteries. And there's four different categories of buses. There's a small bus where you have typically a 4 to 6 pack complement, and then there's a mid-sized bus that has maybe 8 to 12 battery packs. Then you've got the larger 40 to 50 foot bus that will have typically 12 to 18 battery packs in it. And then you have the big articulating buses, the really long buses that will carry even more battery packs. But we found out through a few years of production that a standard battery pack for buses was the right architecture and was the most cost effective. So we basically started building more of a standard battery pack for buses. But electric cars, every car manufacturer wanted their own specific design to fit the specific space inside the electric car. So it's interesting that you bring this up, Chase, because there are other applications of using the bus battery pack. And I'll mention that the heavy duty industry, and an old friend of mine at Liaogang started buying these bus battery packs and putting them into construction equipment at Liaogang. And I was in Beijing a few years ago for the unveiling of a brand new series of electric construction machines, a 22-ton excavator, a 20-ton payloader, wow, and a 12-ton excavator. And it was quite fortunate for me that the last month before my retirement, I flew down to be at Liaogang and actually drive these electric machines. And it's quite humbling to be able to handle a huge machine in absolute quiet, other than the grinding and scraping that you have when you pick up rocks and dirt and things like that. So the need for those kind of big machines are quite evident, particularly in the mining industry. The mining industry is fascinated by electric construction equipment like this, because in excavating, during the working of a diesel engine, sometimes these really hot embers come out of the combustion process, and if for whatever reason the backhoe had just dug into a pocket of gas and it's coming out, you don't know it, those hot embers can actually ignite the gases coming out of the mine and blow it up. So there's a lot of interest in the mining industry. There's also a huge incentive for doing this for urbanization, because large cities, when they're doing lots of construction, these big machines create a lot of smoke. And I know you've seen it. When these excavators are digging a lot of dirt, they belch out a lot of black smoke from the diesel combustion process. And typically they're using dirty sulfur diesel. And so these electrified machines, I think, is going to be the wave of the future and be a big help to reduce pollution in our world.
Yeah, I mean, it seems like there's a huge opportunity there, not just from environmental pollution, but also, like you even mentioned, noise pollution and the torque that you could probably put into these, along with the pneumatic systems they already have, to make some pretty powerful systems. For just like I said, out of curiosity, for like a average electric bus, would that be like 300 to 500 kilowatt hours, or what kind of, is it closer like a full megawatt for the energy that was usually needed? I really don't know much about, I've always thought it made sense, because like you said, the energy density requirements. And I can't imagine most buses go more than maybe 90 miles, if maybe even 50 a day. So it seems like a great opportunity for them.
Yeah, Chase, I want to be careful how I answer that question because
Gotcha.
each and every bus configuration is different, and the amount of energy that's put in will be different based on the need for the application that it has. But you can imagine that those battery packs could have anywhere from 10 to 15 kilowatt hours per pack, and if you got 10 to 20 of those at a bus, that's a lot of energy, right? So it depends on the purchase order for the bus manufacturer, but suffice it to say that it gained a very fast recognition with the Chinese government because it was reducing pollution and saving lives. Even Premier Li Keqiang, during a dinner one night, he mentioned to me that he was thanking Robin Zeng and CATL for the job that they did in reducing the amount of pollution in China by helping make electric battery pack systems for buses. So
wow.
It was quite a rewarding accolade coming from Premier Li Keqiang.
No kidding. Given just the popularity and this overall success, it sounds like, of buses and that the EV market in China, obviously regulation plays a big part into it. What do you think is maybe part of the reason it hasn't taken off as much in maybe North America? You're starting to see definitely a lot more interest in Europe, and some of that's due to regulation. Is there anything you can share? Is that really what needs to be there to kind of get the process and kind of get that first momentum started? And then as more and more people are exposed to the technology, it just really kind of proves itself?
Well, clearly the economic incentives were not provided in the United States for this kind of growth. And that's why China blossomed like they did. And I believe this is why we're seeing the same kind of growth in Europe. If you go to the Northern European countries, up in the Norwegian countries, there's huge electrification going on there. You can see that's also happening in UK and France and Germany at an accelerated rate because the governments of those countries in the European Union are saying, enough's enough. It's time for us to go to electrified vehicles because they will help us clean up our environment more rapidly. And I know that the United States has been very slow in doing that. And as a guy that helped worked on the EV1, where they called all the cars back and crushed them back in 1997, 98 timeframe, it was really kind of aggravating, to say the least, that you work your tail off to make a beautiful electric car, and then because the rollback of the CAFE requirements by the federal government gave GM the opportunity to call back the cars and have them crushed because they did not want to declare it as a production program. All those cars were leased, and because they were leased, they could legally call them back, and they didn't have to provide spare parts for the next 15 years because it was not a declared high production volume production program. So yeah, there's a bit of a sore spot there for me because of that.
No, I'm sure. I mean, to be so far ahead and so early on, and I mean, I have, and I'm sure probably a lot of people listening to this have seen Who Killed the Electric Car. It was a wildly popular product and program, and it's unfortunate that it took so long.
Well, it's for one of the guys that had to live it, and it was during that time that I had such a strong appreciation for the power of electrification and what it could do for us. Now, during the speech today, it was kind of an interesting thing that I had to make the pronouncement that there's still a lot of people out there that want to throw rocks at electrified vehicles because today there's still a heck of a lot of energy that goes into making the raw materials to build the battery pack systems that go into making electric cars. But I have a huge amount of confidence that we will figure out how to make these raw materials more cost effective and more energy friendly in a way that it doesn't require so much fossil fuels or energy to be consumed during the production of these sophisticated raw materials that go into building battery packs. A dear friend of mine who's a very smart guy helped me with the calculations one day, and he said for Model S Tesla, it takes about 42,000 miles of driving time to get an equivalent of zero net emissions. and greenhouse gases and CO2 pollution from the processes that are used to make the components that go into making the Model S battery pack system. Now, I've not confirmed that with Tesla or anybody else, but this guy's a pretty smart guy out of MIT.
Well, and I think that, I mean, still, it's even wild that there is even a car that can do that. But you're right, the sooner and more effective that they can really bring down how far the car even has to go to have that payback, why not? And I think this is kind of a good transition, obviously, given your career and your expertise in this. I would kind of love to hear, you even just mentioned a little bit about some of the ongoing misperceptions about electric vehicles and specifically the battery technology. Those concerns can be anything from, of course, they could be dangerous because of fires, they're too costly. What do you think is kind of the best way to overcome those kind of concerns, or really to get that awareness that that's really just not the case anymore? And it kind of depends on what the application might be, that as long as it's really designed right, it's not any more different or less dangerous, or in fact, probably a lot less dangerous than the current technologies.
Well, not to go rehash the speech that I gave this morning at the battery show, I was giving an impassioned speech on this very topic as my 5 golden rules: safety, performance, life, cost, and environmental. Well, the safety factor, what I put in there was a concern about fire hazard. And fire hazard is a legitimate concern in the industry, but it's up to guys like myself and other engineers to help make these battery systems safe and effective. As you know, there's over 200,000 gasoline fires in cars every year. So, but if there is a fire in an electric vehicle, it hits the front page of every newspaper across the country. So
the headlines and the stock prices of every Tesla and everything,
So it's a bit of just like the media today, and I'm not throwing rocks at the media because you're part of it. Not all media people are bad people. It's just that sensationalization sells papers or sells news, right? But it is a fact that I think the last number I looked at was over 240,000 gasoline fires a year in the United States caused by gasoline. But there's only a handful of fires each year in electric vehicles that were not caused by some accident. So just like the gasoline leaking out of the car, where fire departments are trained how to handle that, we're now in the process of teaching our first and second responders how to handle electric vehicles in those same kind of situations. A dear friend of mine who's the chairman of battery safety in SAE International, in fact, there's 2 of them that are working specifically on the safety for first responders and second responders, as well as the standards for the cell and the modules of the packs themselves. So it's quite important that people understand there's a huge amount of effort going in right now to improve the safety of the technology. And that means we're using different types of barriers. We're using different kinds of intumescent materials, heat transfer materials, charge control systems, thermal management systems, all to help us with that management of the safety of the technologies we build it into vehicles.
Yeah, I'm kind of curious on that. Do you see, it might be valid that it's kind of a little bit of everything approach, but I'm just curious if you're seeing most of this be kind of come from the chemistry side of the batteries, or is kind of software and a lot of just having good battery management systems in place really able to prevent a lot of these issues?
It's a combination of all of that.
Yeah.
It's Chase, it's not a matter of any one of those that's more important than other. It's a combination of all combined. We have pushed the technology in chemistry to get higher and higher energy densities. And as you get higher and higher energy densities, the concern becomes higher for the potential for fire or combustion. But as engineers, we're also learning that you can make the molecular structures inside the active materials so that they are safer and less prone to ignite, depending upon what is the root cause of the ignition. This morning in the speech, I gave about 8 different things that can happen that will cause a battery to ignite. But we control all those metrics that are controllable through battery management systems, proper charging, proper discharging, monitoring of the system, alerts and notification to the driver of the car if something's going wrong. So there's lots of design criteria that go into all the cars and to the battery pack manufacturers that help make these battery pack systems safer.
No, and that's great to hear. And I think talking to you and quite a few others in the industry, it's become pretty clear that this isn't something people just cast aside. There's a clear need for this, and it's being addressed. So going away from that, not the misperception about safety, but the misperception about cost and production. As someone who worked at CATL, where do you see kind of the growth happening, or kind of the next opportunities in manufacturing? Is it really having more factories on different continents? Is it trying to get greater output per factory? What do you think will kind of help really with the scale and get more of the technology out there to lower the cost?
Well, clearly the battery packs are big and relatively heavy. You don't want to ship those things any further than you have to. So localization is a big deal. So you want to try to put the battery plants as close to the car build plants as you can. And the reason, again, is the mass of the battery pack, once it's assembled, is a rather large and difficult thing to ship. And in many countries, the governments are still trying to figure out what the right methodology is for shipping and transportation. So they impose these really big, heavy containers to put the battery packs in to be shipped from point A to point B, because they don't understand how safe or how unsafe a battery pack can be because of the way it's handled, right? So they take a tank and put it around the battery pack and ship it. So that's just a joke. But in all seriousness, localization is extraordinarily important for keeping the price down of the delivered battery to the car manufacturer. And also, many of the car companies that practice just-in-time inventory management, you have to be really on your toes to get the battery pack delivered just in time and in the quantity they want. And in China, just like in the United States or Europe, natural disasters happen. We have floods, we have tornadoes, we have snowfall, we have ice storms. So you always have to have a backup plan of how to get the batteries from the assembly plant to the car plant on time, every time, or you create chaos downstream.
Yeah, and I think that is kind of highlighted with what we keep seeing in the media, I think, with a lot of these kind of stories about cars being delayed. And I think a kind of portion of that also goes to, obviously, what happened recently with COVID and just kind of throwing a huge wrench into the global shipping and manufacturing distribution systems. Going to what we've kind of discussed where your background, where batteries are right now and where they've come from. Where do you see batteries headed? Where do you see as kind of like some of the, whether it be new technologies or just greater awareness, where do you see battery technology, especially for like electric vehicles or grid storage, headed?
Well, it's headed down a very rapid path, I can tell you that. Regardless of where we think we are today, I believe there's going to be major breakthroughs. Since coming back from China, I've identified at least 3 or 4 companies in the U.S. that's going to make some major breakthroughs that will actually leapfrog some of the things that you and I talked about during Tesla Battery Day review. And I work with those companies, and those are going to happen. Some of these things are going to reduce costs dramatically. It's going to increase production capabilities. It will decrease the total amount of capital equipment that's required to build batteries. It will take less floor space, less utility costs, and a lot less environmental contamination from the manufacturing process of these sophisticated batteries. So I think that batteries are headed down a technology path that's going to be lower cost, higher production volumes at much reduced cost than where we are today. Now, you might ask the question, well, what is the gotcha? Where's the pinch point? The pinch point is going to be the raw material availability. Raw materials, many experts in the industry are worried about that because, particularly here in the United States, it takes roughly 10 to 12 years just to open a new mine. If somebody finds a new vein of, say, a lithium salt or something, it takes a long time to go through the process. Now, many countries have broken down those barriers for the mining operations. And there's some companies here in the United States that are working very aggressively in Washington, like Benchmark Minerals, to try to reduce the total time it takes to get new mines commissioned and get them up and running to address that specific issue. So I think if you ask the question, where's the bottleneck? The bottleneck, I'm sure, is in the raw material side of it, because it sure isn't for the sake of manufacturing. The manufacturing side just requires a lot more capital, and we can build a lot more batteries. So that's really not the issue. But then you might start asking questions about, well, where are the other most interesting points for the consumer? Consumers like to be able to charge the car faster. They want to be able to go farther. So consequently, you have to have new technologies that allow us to charge faster, and you have to have technologies that give you higher energy density so you can go further. Now, most of the technology that we have today is easily propelling the car down the road at over 300 miles, which is pretty typical of a gasoline-powered car. And typically the price point for many of the cells from these large manufacturing companies are getting down below $100 per kilowatt hour at the cell level. In fact, some of them are much lower than that. Depends on the purchasing contract, how big it is. And then you got to build it into the battery modules or the battery pack, depending on whether you're going from cell to pack, module to pack, or cell to chassis, which is one of the new things that's going to be the wave of the future. And that's something I've been mentioning for years, that cell to chassis will be the future of electric vehicles, where the car manufacturers will build the chassis in such a way that the manufacturers can deliver the cells and be packaged directly into the car. So I think that's really the wave of the future for where batteries are heading.
And is a big portion of that, I know obviously we even discussed this on the previous conversation we had around Tesla's Battery Day. They were talking about this, and while I think they probably got the most publicity about it, they're not the first necessarily to really be going down this path. Do you think now, is it partially just because batteries have now gone to a point where their kind of lifespan and degradation has become so predictable that this is kind of making it become more of a reality to have kind of this chassis integration? Or what's been kind of the thing that's been holding that or been preventing from that from happening?
Well, what we're finding is that these batteries are fully capable of lasting the lifetime of the vehicle. So as long as you don't have some kind of an infantile mortality of some type with either a cell or other components, and 98 or 99% or greater time, it's not the cells that cause the problem in the battery pack, it's some other component, or a fastener, a wire, or a solenoid, or a switch, or something that causes the battery pack to be returned back to the manufacturer for repair, because these things are fairly complicated. They're very sophisticated in terms of the total number of parts and the methodologies that are used in the manufacturing plants to put them together. So I was in an SAE meeting not long ago with some of the senior guys, and somebody made a comment, well, these battery systems can't be that complicated. And one of the other guys, before I could speak up on the executive management, says, you don't have a clue what you're talking about, because these battery packs are quite comparable to the sophistication of an internal combustion engine and or a transmission, or both combined. So there's a lot of technology in a battery pack that people don't see, because it's not a moving part. It's not something that's right there in your face, because it just sits there. But all the software, all the hardware, and the development effort that went into those, it's just a chunk of material sitting there in a box but it's got enormous amount of power and energy in it.
And it's funny you kind of bring that up, because I do see, I think the tone's changed even within the last year, but there seemed to be this almost, I don't know if it's hubris or what, but a lot of the traditional automotive manufacturers were like, oh, this will be easy. We'll be able to make the transition to electric vehicles. We've built combustion engine cars for years. What's so hard about going to an electric car? Do you think it really is maybe just ignorance, or they're just believing that maybe they can just go to like an LG or some supplier who will have this kind of off-the-shelf solution for them?
I think it's a typical growth curve of understanding. I don't think it's ignorance. It's just a misperception of what it takes to do the job. It's not any different than where we've developed. You know, back in the 1960s and 70s, when I was a child and a young man growing up, I always heard my family talking about all the car fires. People were getting incinerated in gasoline car fires. And boy, that disappeared. Not long after the late 70s into the 80s and 90s, you never heard about car fires anymore, because the discovery of bladders inside the gasoline tank, different types of gasoline tanks made them very safe. So you stopped hearing about these horrific accidents where people were getting incinerated in their cars, because the engineering world stepped up their game and created safe and effective systems. And it got safer and safer and safer as it went along. And now I can go back and remember some of the presentations that I saw at SAE over the years, when we integrated seat belts, where we integrated airbags, we integrated anti-lock braking systems that came out of the aerospace industry. So you can just go down a list of all the types of safety items that people have done over the years for automobiles. Now we're getting into a whole new era of autonomous vehicles. These autonomous vehicles are extraordinarily complicated, but they're also extraordinarily safe. They've got LiDAR, they've got radar, they've got early detection systems, control. Driving my wife's car on a long trip not long ago, the first time I put the thing into cruise control, I thought, this thing is following that car and it keeps slowing down because it's measuring the distance between me and the car in front of me and the speed that I'm going to make sure that I can stop in a safe way. And if I got too close, the car would slow itself down. So I see this is happening across the board in every car company around the world, where they're integrating some of these autonomous features, even in the kind of cars we have today that we are still required to steer.
Right. And no, I think autonomy, especially with electric vehicles, is such a clear next step for automotive space. Where do you think maybe some of the misperception you're talking about is just maybe the underestimate of like how much, like you said, software is involved, and that's kind of a new arena for a lot of these companies with the shift to electric and autonomy?
Mm-hmm. Oh, absolutely. People don't understand. There's an enormous amount of software that goes into the charge control mechanisms for battery, how to handshake with the different kinds of chargers that are out there. There's the brake blending function, where the energy management controller on the car has to communicate with the battery management system. Battery management system has to provide the feedback to the car controller, saying, "Look, I've got a full battery pack. I'm going downhill. You're gonna have to use friction brakes, or you're gonna have to burn off the energy a different way because the battery pack is full. Or if I'm going down the hill and I'm at a low state of charge, I want to pump every electron I can into that electron fuel tank called the battery pack system." So yes, there's a tremendous amount of software in there. Every car company and every battery manufacturer work very hard to make sure that that handshake occurs between the battery system and the car to assure that they're getting the optimum use of that. At the same time, the car manufacturers are working very hard to try to decrease the amount of energy that's being consumed in the car in all the other functions that go on. And I'll use start-stop as an example of that. That's kind of a precursor to the electric vehicle. Many of the European companies were the leaders in this, where they took the engine and shut it off every time the car would come up to a stop sign, and then restart it. So they had to change the architecture on the motor and the generator configuration to be, in some cases, one and the same. So there's a lot of technology that's been developed over the last several years that's leading us down the path to a fully electrified vehicle. But my disappointment in some of the architecture is that many of the components today still use 12-volt components in the cars because that part of the industry has not stepped up to the fact that we're going to higher and higher voltages, when in fact many of those components actually work better at higher and higher voltages. So there's still a lot of work to be done in this electrification world that we're working on today.
Yeah, that's a great call out about the 12-volt kind of archaic architecture. That's almost kind of a vestigial past from the current automotive space. That it is that to me seems to be one of the underrated areas for improvement. And I think suppliers will be able, whoever can really tap into that and start offering these kind of updated systems will be able to make a lot of money that way. Mm-hmm. We've obviously talked a lot about EVs, but with grid storage, where do you see, as someone who's exposed to many different types of battery technologies, do you see grid storage, especially when you start getting to the utility scale, do you see that being something that would be a kind of a cell lithium ion solution? Or do you think that starts kind of getting into maybe a bit more of the exotic ideas for like a redox battery or something like that, where obviously space and weight isn't as big of an issue, but you really just need that kind of ongoing support and being able to deliver a large amount of energy to the grid without having to worry about not necessarily degradation, but just really that stability and safety?
Well, the typical redox flow battery systems have been plagued with high costs and also with high maintenance. At least this is what I'm being told by many of the companies that I've talked with and worked with the last couple of years. But the other thing to consider, Chase, is that the price point for lithium-ion batteries has dropped so rapidly and so dramatically, it's easy to configure a battery system for energy storage with those less costly batteries, and the quality levels are fairly high because the larger the volume of production of a standard design, the better the quality becomes because you have things under control all the time. It's when you get out of control or make the onesie twosies of something where the quality really suffers. So the battery technology going into most energy storage systems today are predominantly a lithium-ion battery because of its energy density and its price point as it's dropping like a rock.
Interesting. And that makes sense. I was just curious if there were any other trends you had seen around that. But I mean, I think that's going to be the big thing at the end of the day is safety and cost. And you're right. Sure. Nothing beats lithium right now for that kind of scale for both of those.
Mm-hmm. Right.
I'm also just curious, kind of going off that a little bit, are there any new, whether that be kind of solid state, any new specific chemistries? Are there any new battery technologies in particular that you're really excited about, or you think are kind of that next step up? I know, I'm sure you probably get this asked all the time, and there's always kind of that fine balance between what is kind of in the lab and theoretical and what's actually going to be something people can buy.
4 years ago, Dr. Michael Thackeray, when he received his Lifetime Achievement Award at NAATbatt International, made it very distinct. Somebody asked him that question. His response was advanced lithium. Okay, what does that mean? Advanced lithium is a continuation of discovery of new chemistries, new electrolyte systems, new cathode and anode materials, whether it be silicon graphite for the anode or whether it be a low cobalt NMC technology for the cathode, separator system. So I think Dr. Thackeray was right. There's so many possible changes between cathode, anode, separator, electrode system. Even during Battery Day, when you and I were talking about this on the TV show, the concepts of a tabless cell were fascinating to people, but most people don't understand how that's even possible because they haven't worked in the field of batteries. And those kind of innovations don't come along very often, but when they do, they revolutionize the industry. So I always I think back in my days at Delco Remy, the maintenance freedom battery, the old jingles on the commercials, Delco Freedom Battery, was always resounding in everybody's head, because no longer did you have to put water in the battery. It's under the hood of your car because it's a maintenance-free battery. So these are the kinds of technology breakthroughs that you're going to see over the next several years in the advanced lithium world. Now, to your point on solid-state batteries, this is constantly brought to my table for asking this question. Where are we with solid state? Some companies think they're very close. My contention is I will say that they're close when they can get closer to the price point parity with the liquid state lithium-ion battery in a way that you can produce it in large volumes with the same kind of quality, because anybody that works in manufacturing like I have for most of my career know that, yeah, if you can produce it, that's fantastic, but can you produce it cost effectively and with low scrap rates? Because most of these solid state products, the only solution that you've got once you've made that battery is you send it back to the recycling facility to recycle it, because you can't recover it any other way because they're not repairable. So there's a lot of things to consider when you start talking about solid state batteries and where they fit into the marketplace today. Not that I'm trying to dissuade people from doing it, because I think it's a great idea. It's just the implementation using some of the technologies like vapor deposition, different kinds of laydowns and different kind of coatings and processes. They are yet to be proven in a high volume production scenario that is cost effective, particularly when you see a year over year reduction in the price point of a liquid state lithium ion battery. So I'm hoping that somebody breaks that barrier and comes out with a solid state battery that we can all use, because it will effectively be a safer product. It gives us the hope of maybe some improvements in the durability aspects, because it is solid state, but I've yet to see a set of data from anybody that says they're going to meet those metrics.
Yeah, and that's a great call out. I think I'm even hesitant to even bring up solid state sometimes, just because I think a lot of people don't fundamentally understand what it means, and they seem to think that just if something is solid state, that is the end all be all, and that's when this technology is going to be ready. And I think what we've talked about today, I mean, where lithium ion batteries are today is phenomenal. It's so much farther than it was a few years ago, and I'm sure it'll be a lot farther in another few years. And solid state has a role to play in that, but it's more, I think, of a stair step than a complete revolution. There's some it would be a big stair step, but no, that's great to hear, and I think pretty well aligned with kind of a realistic expectation of what will happen. One thing to kind of go in a little different direction, as someone who worked at CATL and work very closely with a lot of these global OEMs, where do you see a company like Tesla that does the full integration of, obviously they do partner with LG and Panasonic, but they seem to be taking a fairly hands-on approach to this compared to some of the traditional automotive companies that might be deferring a bit more to their partners like LG or other battery companies for supply for the actual pack. Do you think that for these companies to really make that effective transition, that they need to be more hands-on with it, or will the supplier market be able to kind of help address a lot of those concerns, you think?
I am not sure I understand your question, Chase. I apologize. It's not quite sinking in. It's
No worries. I got a message come in at the same time, so I was trying to remember, understand what I'm saying, and trying to ignore the message too. What I'm asking is, do you think Tesla's approach of being very hands-on to the process of kind of the battery and the cell versus the kind of media representation that a lot of the traditional automotive OEMs are defaulting to a solution from a supplier, do you think that's really accurate? Or as someone who's actually getting to work pretty closely on the front lines of this, you're seeing the more traditional auto OEMs take that aggressive approach. They might just not be as vocal about it.
Well, it's just because the media doesn't see what's going on behind closed doors between the car manufacturers and the battery manufacturers. These car manufacturers are extraordinarily interested in what the battery manufacturers are doing. They're in meetings with the battery manufacturers constantly to assure that the battery systems that the battery manufacturer is making meet their expectations. I mean, I'll use General Motors as an example because I worked at GM for 21 years. The car companies were intimately involved in what we were doing with the battery because they wanted to assure that the battery met its intended objectives. And even though they give you a technical specification, they want to sit in your pockets so they know exactly what's going on and assure that you're meeting their expectations. And today in the electric vehicle world is no different. If you look at what the General Motors did on the Chevy Volt, what they've done on the Bolt, what they're doing in the new cars that they're releasing, they are very closely tied to the battery manufacturers that are providing them the battery and giving them input, both on the technology side as well as the technical specification side. And that's no different than the BMWs, the Volkswagens, the Fords, the FCAs, all the Chinese car manufacturers are working very closely with their battery manufacturers. So BYD is a good example. Vertical integration at BYD is not that different than what you see Tesla doing. So it's not uncommon, but it's not that the battery it's not that the car manufacturers themselves want to be the battery manufacturer, even though they dabble in joint ventures with battery manufacturers. You don't see a lot of the car companies making the batteries themselves.
Yeah, and that's a great example with BYD. They are, I think maybe here in North America, people don't hear as much about them, but they're doing exactly kind of what you're talking about of taking, and they've been a leader in this, where they really take that hands-on approach. Another question I had for you is, speaking of BYD, CATL, Panasonic, LG, the vast majority of these battery manufacturers are either in China, Korea, Japan, kind of in Asia in general. And do you think that's partially one, because that's where a large interest in making this initial investment into batteries and EVs was started with China? But do you expect to see more players kind of enter this space? I know there's one like called Northvolt in Europe, but just domestically, the only thing people have heard about is kind of Tesla and then Tesla's partnership with Panasonic. Do you think it's going to really take that interest and that kind of supply chain step up for us to see something of a CATL or another LG Chem start here in the US? Or do you think it's going to just continue to be partnerships with these existing companies?
Well, it's a very interesting question, and I've got mixed feelings on it, by the way, because I was a part of the team that did the reviews of the first round of federal funding back in the Obama administration time period, where they doled out billions of dollars to companies to make batteries. Now, at that time, I was president of Magna E-Car. Instead of taking the money that we got from the federal government and building any kind of manufacturing capacity, I put it into testing, because at that time, I felt it was more important for us to understand the capabilities of the batteries that were being produced than to go produce them in the first place, because there was no market for them at the time. And I wasn't wrong at the time because we really didn't have a market for those batteries if we produced them. And so I believe now 3 out of the 4 that were in the state of Michigan either went bankrupt or at least went bankrupt or sold out because they could not make money making electric vehicle batteries at the time. Now we're seeing maybe there's a change in the mix. And I think a lot of that's going to be more around when the car manufacturers start producing the electric cars the battery packs can go into.
Gotcha. I want to be respectful of your time. We're kind of coming up on the hour here. So one final question. This has kind of been a theme throughout, and even what we just talked about with your work for kind of the Obama administration, with a new administration coming in and just kind of where we're starting to see a lot of more public interest around electric vehicles. What do you think are some of the things that government could do to really help incentivize and kind of get more electric vehicles on the road? Is it kind of continuing to do a cash grant, or is it maybe trying to just promote domestic engineering of electric vehicles? Anything you could kind of share on that?
Oh, absolutely. Because of my role as the CTO of NAATbatt International and my past role as Chairman Emeritus at NAATbatt, we've started a huge effort inside that professional trade association to address the key topics of our times. And little did we know that in the background, the U.S. federal government over the last several months have been putting together a consortium. They now have officially given it a name, the Federal Consortium of Advanced Batteries. This is headed up out of the Department of Energy, but my recollection is approximately 40 different departments in the federal government that are participating in it. Everything from any one of the departments of energy, Department of Defense, Department of Transportation, all the D level type of government agencies, the Treasury Department, a lot of different parts of the federal government organization are actively involved in this because they see what happened in China. They see what's happened in Korea and Japan with the electrification effort, particularly with batteries behind it. We also see there's a dire need for having electrification, not only in the transportation sector, but also in the energy storage market. Those play off of each other. Talking about new revenue and taxation, new opportunities for jobs. We're looking at a whole new revolution of university curriculums for students to learn how to turn technology into cash when they build battery systems. So talking with Mitch Daniels, ex-governor of the state of Indiana for 2 terms, he's now the president of Purdue University. Last January, I met with Mitch, and Mitch told me point blank, he said, Bob, I'm really anxious to hear what you got to tell our faculty and our students in the speech you're giving this afternoon. Unfortunately, he said I can't attend, but I got some really interesting comments back from the faculty saying, gosh, we really need this kind of industrial input. So the industry not only is getting input from the government that they are doing something now and we're interfacing with them, but we as an industry and as a federal government need to close that loop back to our universities so that we can get that closed loop educational process brewing right now, because it takes students 4 years to get out of college and go out and get productive jobs. So we really need to focus right now on what the federal government's going to do to help the industry, what the industry is going to do to help the federal government, and what both the government and the industry is going to do to support the universities to educate and train these young students on how to electrify vehicles. It's a whole new breed of engineers, I think, that's going to be coming out of the universities to fill the roles for these future electrified machines that we're building.
Well, I just want to say that I think is a spot on and great answer, Bob. And with that, I just want to say thank you so much for your time today. Definitely look forward to speaking with you again soon. And this has been incredibly fascinating. Thank you.
Well, I really appreciate you thinking of me, and we have to do this again sometime. Maybe on a different topic.
I would love to hear more about the. I believe you said Tigris and that whole project. I think that could be a whole nother conversation to itself. So with that, I'll let you get going, and we'll talk soon.
All right, Chase. Thank you very much. I certainly appreciate it.
Thanks for joining us. Be sure to visit our website, connectingthegrid.com. There you can listen to our podcasts, contact us about sponsorship, or even be a guest on Grid Connections. While you're at it, if you found value in this show, we'd appreciate a positive rating on your favorite podcast or video streaming service. Or if you'd simply tell a friend about the show, that would help us out a lot too. Thank you again, and I look forward to us learning more together soon.